Hello students, welcome back. Today we will start with our module number 8, which is basically about some of the devices in which solar energy is used. Okay, so last class we studied about different solar energy collectors. So it was a method to collect energy only, but it was not used for any fruitful purposes. But here we will directly use the energy for some fruitful purposes. So let us see one by one. Okay, so starting with the solar energy device. Okay, so first device is solar cooker. And you know a typical cooker, how it is working. Actually with thermal energy you can cook up any food, but here instead of any other energy we will be making use of solar energy for cooking purpose. So it is a device which uses energy of sunlight to heat, cook and pasteurize. Even you can pasteurize many drinking material, beverages. So like that, even for industrial cooking you can make use solar energy. So we will study about such a solar cooker. So anyway, it is very cost effective because energy is available free of cost. So we can say it's an inexpensive method of cooking. And in fact there are 3 types of solar cookers in terms of its design, its structure, the way of working. You can classify the solar cookers into 3 ways. First category is called box type solar cooker, and the second one is called MultiReflector solar cooker, and the third one is called parabolic disc concentrator type of solar cooker. These are the 3 categories of solar cookers. Okay, so let us see one by one. So typically how it looks like. So box type looks like this. There is a box inside which is kept, and in a multi-reflector cooker you can see how the cooker is kept inside. The details we will see in the subsequent slides. And parabolic type of cooker. The visual appeal shows how it looks like, and working also we can get some idea about the working of cookers. Okay, let's see for the first one, fast plate solar cooker. Okay, so there is a flat plate. Which is the flat plate? This is the flat plate. This essentially acts as a transmitter. Okay, it's made up of glass or some strong plastic, and your cooker is kept inside the box. And once the lid is closed, it is closed, what happens? Sunlight gets fully trapped inside it. Based on the greenhouse phenomena we studied earlier, the solar radiation gets trapped inside, and the cooker absorbs the radiation. So the construction involves these main things. But solar energy is entering into the double-walled glass door. Okay, this is basically double wall, not a single one, and the gap in between, the spacing in between the double wall will be vacuum, so that heat energy will not be reflected back. If there is a vacuum, so moisture possibly energy cannot reflect back. So that's just like in a vacuum flask, you know. In a vacuum flask there is a vacuum space. Because of the vacuum, heat energy is not liberated out. Same way here also, there is a double walling. So the double wall enables to maintain heat inside. Okay, with that heat, the food gets cooked. And at the bottom where the cooker is kept, there is a black sheet. Okay, blackened. So what happens? You can completely trap the heat energy inside. So cooking becomes very fast, and you see, we can achieve a temperature as high as 160 degrees Celsius, because you know water boils at 100 degrees Celsius, but here you can reach temperature as high as 160. So that is appreciably good level of temperature to cook normal foods. Okay. So second type is multi-reflector type of solar cooker. So as the name indicates, there are reflectors are there. So these are all reflectors, okay, of a different shape. It can be square shape, triangular shape, okay, or any rectangular shape like that, reflecting plates. So they are inclined at an angle, they are kept at an angle such that solar radiation strikes on the sheet and get focused to the cooker. Okay. So that way light is collected together in a single point. So cooking happens very fast. So that is the advantage. So the sun rays reflect the solar radiation. The plate reflect the solar radiation into the cooking zone in which the cooking vessel is placed. Okay, and you see you can achieve a very high temperature as high as 250 degrees Celsius, 250 degrees Celsius can be easily achieved. So efficiency of this multi-reflector is much better than that of a box type cooker. Okay, so and of course cost will also vary with the models. And the third one is a parabolic concentrator type cookers. And you know about parabolic reflector, we have studied in one of the earlier module. And for a parabola there is a focus, and your cooker is placed at the focal point. So what happens? The entire light gets focused to a single point. So cooking happens much readily. Okay. Here parallel sun rays. Okay, the sun rays are falling parallelly and they get focused. So what happens? Cooking happens very fast, and you see temperature that we can achieve is much higher, around 450 degrees Celsius can be easily achieved. So that way you can say the most efficient model is parabolic concentrator compared to all other models. So people in many places are widely using these type of devices, cookers, for their day-to-day cooking purposes. Different models are available in markets nowadays. One can purchase and really use them for any domestic purposes. Even at industrial scales, people are using it. The second class of device is called solar distillators. So you know, distillation simply means boiling something, evaporating something. On evaporation, the material gets separated. Okay, so this is a very common process used to separate many materials from, especially in liquid form. Some mixture of liquids, by suitable boiling methods you can separate them. So distillation is basically used to separate a mixture, for example, whereby its components can be separated. Okay, so technically we define distillation is the process of separating components or substances from a liquid mixture. So it is a mixture by using selective boiling and condensation. So subsequent to boiling you have to condense. I mean, so you have to convert it again back to liquid. So on what happens on boiling, it evaporates. So we get what is called vapor, or it is in gas state. So then subsequently you have to cool down, then you will get liquid. So conversion of vapor or gas into liquid is called condensation. So here this method, why this is relevant here, you can use this distillation process to separate saline water, salty water. There are many such places where pure water is not available. Where using solar energy, you can boil, you can evaporate salty water, and you can separate pure water. So this is a very commercial method, handy method to get potable water, drinking water. Okay, so a typical solar distillator look like this. Okay, this is called a basin on which the saline water, salty water, it can be seawater also. It is filled to an appropriate level, and there is a roof. The roof is made up of some high quality glass or plastic. Okay, so then only solar radiation can come into this, and those solar radiation get absorbed by this water. Subsequently it boils due to high temperature, and on boiling what happens? So this is getting into vapor form, and they get stick onto the bottom surface of this roofing. Keep in mind that this roofing is of glass or plastic, high quality plastic. So on evaporation, they get to stick on the surface where they get condensed. Okay, they convert into liquid again. So they what happens subsequently? They roll down along this slope, roll down, and there will be a trough here, something carrying container. On the container, these drops fall down. Okay, on this drop fall down, and you can collect them and use for any purpose, for human consumption. You can use it. Okay, this is a simple principle of working of a solar distillation. So it is mainly used in such places where people suffer from fresh water scarcity. Especially in desert regions or remote areas where this procedure is very good enough. In certain coastal belt also, where potable waters are not available, one can use this method to separate good water, fresh water from saline water or marine water. Okay, it is given here in arid and semi-arid places. Arid means completely desert-like place. Okay. Or semi-arid means partially desert, where good drinking water is not available. Of course, in coastal areas where drinking water is not available, one can use the same process. Actually, Kutch, Bhuj areas like in Gujarat state of our country, where this method is used. Even in Rajasthan, there are many deserty places where this technique finds application. And only condition is that where solar energy should be available plenty. Okay, so then this method is very fruitful and effective. So the device is actually called a still. It's a solar still actually. The device name is like a still. So where water is kept in still form. We are not moving it and gradually evaporating. So once it is exhausted, you can refill it with that is called a replenishment. You can refill this basin or this tank with other batches. Okay, so that can also be done. So we call it basin type of solar still because a basin is used here. Okay? So other details of this still are like this. There is a blackened basin. Okay, the basin bottom part should be blackened. It is simply to retain heat energy absorbed. It is black. If it is black, it can easily maintain the temperature. That is the spirit of keeping black. And there is a transparent airtight cover, as I already indicated, made up of glass usually. So it is to allow all the solar radiation to enter into the basin. Okay. And it has shape should be roof-like. Okay, slopey. Why it is slopey? Because when water vapor condenses off the bottom surface, it should come down and get collected in a trough. It should come down and get collected in a trough. So for this purpose, it should be slopey and roof-like. That is why structure is like that. Okay, so I hope things are clear. And this is the principle used. Radiation is transmitted through the transparent cover to the basin and get absorbed by the saline water. Principle we already described. Evaporated water gets condensed at the bottom side of the roofing sheet and flows down to the collection trough. So trough will be at the sides of it. And once it is exhausted, finished, water is finished, you can refill it. Okay, refill it. So this is the last one, what is called a solar greenhouses. In one of the previous modules, we in fact discussed about solar greenhouses. I hope you remember it. Basically, it is used to grow plants, vegetables, and other things in such places where people experience heavy winter. Because in heavy winter, people can't grow vegetables and flowers, food materials. So, for growing vegetables, we need ambient temperature. During heavy winter, temperature goes down to -degree Celsius. Okay, So this is made possible by using greenhouses. So it is a structure with walls and roofs made of transparent material such as glass or strong plastics, in which plants requiring regulated climatic conditions are grown. So this is the thing. These structures range in size, from small sheds to industrial sized buildings. Even for commercial purpose it can be used, for domestic purpose it can be used. So depending on the requirement, the size can vary. And usually it is exposed to sunlight. That is a very primary requirement for running a greenhouse. And it becomes significantly warmer than in external temperature, protecting its condensing quality. That is the very purpose. And we know it is used to cultivate vegetables and flowers. What is the fundamental principle? The physical principle is very simple. The incident radiation, the falling radiation, whose frequency is high. So what happens? That can easily penetrate through the glass cover or plastic cover. Once it reaches inside the greenhouse, what happens? It is absorbed by all the objects. Whatever objects we have placed inside the greenhouse, they absorb it and the re-emit. That's another phenomenon, re-emit. When it re-emits the radiation, its frequency is slow, frequency is small now. So frequency small means its energy is small. So energy small means they cannot penetrate anymore to the greenhouse. So what happens? They get trapped inside. So this trapping leads to warming. Once energy gets trapped, they get warm. Just like when suppose you are outside in a car, and suppose your car is exposed to sunlight, and you close all the windows, then what happens? As the time progresses, the temperature inside the car will increase, until and unless you have not switched on your AC, air conditioner. So that is also greenhouse, because the trapped energy, quantity of the trapped energy increases with time. So you feel more and more discomfort. So that is why whenever we are traveling in a closed car, we are compelled to switch on our air conditioner. Otherwise we feel too much hot. The reason is the same, greenhouse effect. Same phenomenon is happening here, provided that there is no air conditioner used here. So as the time progresses, temperature inside a greenhouse increases. So that is what is shown here. The re-radiated energy from such objects cannot penetrate the roof because it's reduced the energy and frequency. That's the reason. So energy gets trapped inside the house. As a result, temperature inside the greenhouse rises. This way, many plants which are otherwise perishable in called geographical regions can be effectively grown. Otherwise, mainly in European countries, vegetable cultivation would have been very difficult. It is made possible by these techniques. So this is a typical view of a greenhouse. You can see it's a very gigantic structure. You can see human beings here and there. So this is a long view photograph. So such huge structures are used to cultivate vegetables and other food materials in such countries which are located in nearby to polar regions. You can see temperate and low temperature regions. So I think this is clear, the idea is clear. And now the turn for assignment. Write a brief note about the following types of solar cookers. You need to write a brief note only. Multi-reflector solar cooker and parabolic concentrator solar cooker. So you can have a simple brief, a small rough figure also. You can accompany a small rough figure along with your description. So hope things are clear. Thank you all of you.